Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our video lecture over Section 1C titled Sets and Venn Diagrams. So we're going to talk about sets first. Set is a collection of objects. The members of a set are the individual objects within it, sometimes called the elements of a set, so the individual things inside of it. Usually we write sets by listing a pair of brackets. And sometimes if we have too many things, we use three dots to indicate a continuing list or pattern if there are too many members to list it. And then we're going to use Venn diagrams to represent intersections and non-intersections between sets. So let's just look at a couple examples of sets. So the first set is the set of countries larger in land area than the United States. There happens to be two countries that are larger in land area than the United States. It's Russia and Canada. So they list it in brackets, Russia first, Canada second. Could have been Canada first by alphabetical order. And then the second set is the set of natural numbers greater than 5. Now natural numbers are your counting numbers essentially. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Alright, so if we're talking about the numbers greater than 5, we're going to start at 6 over here. And then we have 7 is the next one, and 8, and then a dot, dot, dot. Just saying that the pattern continues, so 9, 10, 11, 12, etc. It's kind of like dot, dot, dot is kind of like etc. So sometimes we'll see sets listed like that. If A is a subset of B, then all members of A are also members of B, so that would look like that. Here's a Venn diagram of that picture. A is the subset. If they're disjoint, then two sets have no members in common, so that we draw the Venn diagram where there is no intersection between the two sets. And if they overlap, then the two sets share some of the same members, so that's the overlap in the middle there. And this is the most common Venn diagram we see, where we have two different categories and they have some overlap, and then the number on the outside is where members that are in neither of those two sets. So we'll look at some examples here. This is a subset Venn diagram where whales are the subset. So whales are mammals, and whales are a subset of all mammals. There's other mammals like lions, tigers, bears, stuff like that that are mammals, and us. But whales are just a part of that subset. So mammals would represent this circle with all the other animals that are not whales. And then the non-mammals, like fish and things like that, are going to be out here. Alright, now if we look at the set of fish and the set of mammals, fish are not mammals. Alright, so there is no intersection of fish that are mammals and mammals that are fish, so they are called disjoint. Then we have the other animals that are neither fish nor mammals. And then lastly, this is an intersecting diagram, an example of an intersecting diagram, where we have the set of doctors and the set of women. Alright, so it's very good to look closely at this Venn diagram and understand what these four regions tell us. Now, remember, there's four regions. The region here on the left, which is just the light blue, the region here on the right, which is the pink, and then the region in the middle, which is the intersection, the darker region, and then the region outside. You got to think of it as four different regions, and you got to be able to find all four regions. Okay, so since this is doctors, but out the light blue section is doctors, but not in the women's circle, we can assume that they are male doctors. And if we're in the women's circle here, but not inside the doctor circle, inside the intersection, we can assume that these women are not doctors. It's really important to understand. The intersection in the middle are the female doctors. They're both of these characteristics. So the inside's usually the easiest to understand. The left and right, you have to understand that if you're on the left here, you're on this category, but not in the right one. And if you're on the right side, you're part of the right category, but not in the left one. Lastly, on the outside, these are the neither nors. Okay, they're neither doctors nor women, so we say they're men who are not doctors. Alright, so understanding how to define these four regions is really important when you do Venn diagrams or answer questions about Venn diagrams. Describe the relationship between Democrats and Republicans. Here's another one. Democrats and Republicans are disjoint. You're either with one party or another. Other political party members would be on the outside. All right, now you're going to have some questions over the number system. Natural numbers are counting numbers, so we start at 1, 2, 3, 4, 5, things that we see in nature, okay? Then whole numbers add the number 0, all right? Whole number, so if you took 1 minus 1, you would have 0, and that's how we have the set of whole numbers. So natural numbers are your counting numbers starting at 1. Whole numbers are your counting numbers starting at 0, okay? So the only thing the whole numbers get, or the only thing more that the whole numbers have is 0. Then integers. Integers have all the whole numbers and natural numbers, and then all their negatives. So integers can be like -3, -2, -1, 0, 1, 2, 3, etc., etc. Then next is the rational numbers. These are numbers with decimals. They're numbers that can be expressed as fractions. So like 2/3 or 1/7, or even just the number 4 is a rational number because you can express it as a fraction of integers, 4 over 1. So now we're picking up all the fractions, all right, and decimals. Then we have what's called irrational numbers. On the real numbers really is the whole set. Okay, you're a real number if we're dealing with any number you've pretty much seen in the real world. But there is a subset of real numbers that isn't inside the rational numbers called the irrational numbers. This is like our number pi, or the square root of 2, or the square root of 3. And has a decimal that goes on forever and ever and ever, and a pattern that we can't terminate or show. So those are your irrational numbers. A lot of square roots, if it's not a perfect square, is an irrational, or pi, because it can't be expressed as a fraction. And real numbers encompasses all of these numbers. So you will have some questions over that in your homework. It's not the hugest focus, but it's good to practice this subset relationship. All right, then for Venn diagrams, we're going to look at what's called a two-way table to construct these. Some problems will have that, some won't, but either way, the two-way table will help us understand the relationship between the 4 different sets. So we did there was a study designed to learn whether a pregnant mother's status as a smoker or non-smoker affects whether she delivers a low or normal birth weight for a baby. So they looked at 2 things: was the mother a smoker or not, and was the baby a low or normal birth weight. So there's really 2 questions that they asked, which gives 4 different regions. Yes or no for the first question, and yes or no for the second question gives us 4 different regions, and we'll see that in a table. Okay, so yes or no for the first question was the mother's smoking status. She was either a smoker or a non-smoker. And then the yes or no for the second thing was the weight of the baby, low birth weight or normal birth weight. And that gives 4 different categories that we set up in a cross tabulation here. So it'll be good to describe these 4 regions in a list here, and then that'll help us draw the Venn diagram. And from there we'll summarize the results of the study. So looking at this, the first thing I think they're going to do, is the upper left-hand corner. Okay, the first category is mother's smoking status. So of the there were 18 women who were smokers and had a baby of low birth weight. Okay, so that's what we're saying here. 18 babies were born with low birth weight to smoking mothers. That's the upper left-hand corner. Then the upper right-hand corner is the 132 babies were born with normal birth weight to smoking mothers. So that's this upper right-hand corner. So normal birth weight, smoking mothers. Then they're going to say low birth weight for non-smoking mothers is 14, and normal birth weight for non-smoking mothers is 186. 14 were low birth weight to non-smoking, 186 were born with normal birth weight to non-smoking mothers. Then we could draw the Venn diagram. So the first thing that they asked was smoker or non-smoker. So you'll see on the Venn diagram here that the left category, the left circle is just the yes of that first question, smoking. Then the second question they asked, the first response is low birth weight. So they just decided to mix this with this. Remember, we do not want one circle to be smoker or non-smoker, because then it'll look like 2 separate circles, because you're either a smoker or a non-smoker. Those are disjoint. but there is an intersection between the smokers and the low birth weights, or the smokers and the normal birth weights, so we chose these two as our circle, our two circles, excuse me. So smoking and low birth weight. Alright, so remember, define the four regions. The blue region that's outside of the purple region is the smoking mothers. Yeah, it clearly says that, but they're also not of low birth weight, so that means that they're normal birth weight. That's how they come up with that. Alright, remember, if you're in this section, you have this characteristic, but not that one, and not low birth weight is normal birth weight. So going back to the table, smoker, normal birth weight, that's 132. Alright, next, the low birth weight. Okay, these are low birth weights, but since they're not with the smoking mothers, these are the non-smoking mothers with low birth weight. So if we go to the non-smoking mothers with low birth weight, that's the 48 or 14. Okay, the 18 in the middle is the smoking mothers and who have low birth weight. That's the easy one here. Smoking and low birth weight is 18. And then the last one, the number on the outside. Remember, there's always a fourth number on the outside, which is the neither nor of these two categories. So they're non-smoking mothers, and they have normal birth weight. That's this, the 186. So the non-non is this non-smoker normal birth weight, 186. Now remember, there is no overlap between this. Some of these 18 people are not some of these 132, and some of these 18 are not some of these 14. There are other questions that I can answer. For instance, how many smoking mothers are there? Well, smoking mothers, you might just say, oh, well, there's 132. Well, there's smoking mothers, there's 132 smoking mothers who had normal birth weight, and 18 smoking mothers who had low birth weight. So there's actually 150 smoking mothers. They're all contained within this circle. If we were to ask the number of mothers that had a baby with low birth weight, it would be the 14 plus the 18, considering whether they smoked or did not smoke. There's one last question we can say: what's the number of smoking mothers or mothers that had a low birth rate? When we say or, we include either or circle plus the people that had both. So when it asks for or, you add the three categories up. So that's the end of this section. Good luck, and we'll see you next time.